going to look at a variable. And so we'll start with a definition for what a variable is. So we can say that a variable is a category that we collect data for. Okay, so it would be like if I went into my classroom and I asked every person in the class how old they were. All right, and so when I wrote my data down, I would list out the responses that I was given. So maybe the first person said that they were 17. The second person said they were 18. The third person said they were 16, and so forth. Okay? And so when I was done, I would have a category, which was age, that I collected data for. All right? So age is an example of a variable because it is the category that I can collect data for. So let's think about some other examples of variables. So let's think about other questions that we may be asked if we were completing some sort of survey or questionnaire. So a lot of times they would ask for gender. They might ask for your income. They might ask for race. They might ask for your weight. They might ask for your religious preference, your religion. So anything along these lines would be considered a variable. It would be a category that we are collecting data for. All right, so just like we can classify the statistics, we can also classify the variables. All right, so a variable is either a qualitative variable or a quantitative variable. And it's a very easy distinction between the two because one of these is going to get the categories where the data is numbers, and the other one is going to get the categories where the data is not numbers. So can you anticipate or guess which qualitative or quantitative would have the numbers? So hopefully you chose this one, because if we look at quantitative, we think about quantity. And when we talk about a quantity of something, that's a way of asking how many. So that signifies a number. All right, so we want to write down for our definitions. Quantitative variables have data that is numerical or that is numbers. And qualitative has data that is not numbers. Okay, so what I'm going to do is I'm going to go back to this slide where we wrote down some examples of variables. We wrote down age, gender, income, race, weight, and religion. And I'm going to classify those examples. All right, so our first example was age. Right, so age, if I ask you how old you are, you're going to give me a number. So that makes it a quantitative variable. All right, gender. If I ask you what your gender is, you are not going to answer with a number. You're going to tell me male or female. So I'm going to put gender up here in something that does not have a number for an answer. All right, income. If I ask you how much money you make or how much money is in your pocket, all right, those are numerical answers. $5, $10, $100,000, whatever the case may be. Income is going to be numbers. All right, race. If I ask you for your race, which classification is that? Okay, that is not going to be a number, so we'll put that here for qualitative. Weight. How much do you weigh? That would be quantitative. That would be a numerical answer. And religion. What religion are you? That would not be a number. All right, so hopefully that seems fairly straightforward. If it's numerical, it's going to be quantitative. If it's not a number, it's going to be qualitative. And so we can classify the variables in that manner. All right, so we're going to take a quick look at an example and just go through and determine qualitative or quantitative. Again, if you would like to pause the video at this point and try this yourself, that is a great idea, and then you can check your answers. Okay, so the first one is marital status. So that would be single, married, divorced, or widowed. That would not be a number. So I'm going to put qualitative next to that one. The time it takes 10 people to complete a New York Times crossword puzzle. Time would be 30 minutes, 50 minutes, whatever the case may be. That would be a number. So I'm going to do quantitative. The weights of lobsters. Right, again, weight is going to be a number, so quantitative. The colors of automobiles in a shopping center parking lot, not numerical. Color is not a number, so I'll do qualitative. Amount of garbage in pounds. Okay, how many pounds? That would be a number, that would be quantitative. Capacity of the NFL football stadiums, that is how many people can sit in the stadium. That would be a number, so that would be quantitative. Ages of people living in a personal care home, quantitative, age is a number. And finally, the different species of fish sold by a pet store, that would be qualitative, that would not be a number. Okay, so that is the first level of classification for variables. So if your variable is qualitative, then you are done classifying. Okay, you cannot classify a qualitative variable any further. But if your variable is quantitative, we go one more step. All right, so a quantitative variable can be classified as either discrete or continuous. All right, so discrete variables are those that can be counted. And maybe you don't have to count them, but you can count them. Continuous variables are those that are measured, and they are most typically measured with some sort of instrument. Okay, so let's talk through a couple of examples here. Let's look at income as our first example. So the question that you need to ask yourself is, do you count money or do you measure money? Okay, so money is typically counted, so I'm going to put income up here as a discrete variable. Okay, what about weight? We talked about weight earlier. Is weight counted or measured? So weight is measured. You have to use a scale to measure your weight. And so it's going to be here as a continuous variable. What about the distance that it takes you to drive from your house to the grocery store? All right, distance would have to be measured with the odometer in your car. So anything that has to do with distance would be a continuous variable. All right, what about the number of people in your household? Okay, and again, that can be counted. Hopefully you don't have to count it, but you could. Okay, so number of people in your house. Okay, so the only one that we haven't really talked about that we've already added as an example is age. All right, so the reason that I left age off for a minute is that age is often a variable that students will sort of argue both discrete and continuous with me. Some students say that it's discrete because we count the years that we've been alive, and other people claim it's continuous because we measure time with maybe a stopwatch or we measure time with a calendar, so time is measured. And so occasionally we get a variable like age where it's not easy to determine which one it is, whether it's discrete or continuous. So I'm going to give you one other idea that you can use instead of the counted versus measured to help you on a variable that maybe is not as clear as some of the other ones. So one thing that's unique about continuous variables is that they can represent any number between two specific values. Okay, so let me try to explain this to you. You have already told me that weight is continuous, right? And you told me that it was continuous because we measured it. We measured it on a scale. All right, so you see on the slide that you have a picture of a scale, and that scale, notice, is a digital scale, and it gives a weight as a whole number. There are no decimals on that scale, okay? So what I want you to think about is if someone steps on this scale and the scale reads 120, I want to know if that person weighs exactly 120 pounds. Okay, and so if you think about it, what if the person actually weighs 119.8? Okay, now knowing that the scale only records a whole number, 119.8, if that is your actual weight, the scale is going to read 120. Okay, what if the person weighed a little bit more? So what if the person weighed 120.3? That was the actual weight. But when they step on the scale with no decimals, the scale is going to bump us back down to 120. Okay, so the person might actually weigh a little bit less or a little bit more than 120, and the scale is going to do a little rounding. So let me ask you this. What is the lowest that the person could actually weigh and have the scale still say 120? Okay, so the lowest possible weight would be 119.5. And then what is the highest possible weight that that person could weigh? And we know just by rounding rules that would be 120.4. So this 120 pounds that the scale is giving us can actually be any number between those two values. And that's what we're saying over here. We're saying continuous variables can actually be any number between two specific values. Okay, so let's keep that in mind. So we know that that's the case for continuous. That is not the case for discrete. All right, so if I ask you how many people are in your household and you tell me 5, you're not really meaning 4.5 to 5 and a 5.4. You really mean exactly 5. Okay, there's no give or take on that number. If I ask you how much money you have in your pocket and you count it, you're giving me an exact value. Okay, so income is an exact value. Number of people in the household is an exact value. But weight, you've got this little bit of give on either side for the scale. Okay, and the same thing for the distance. If I ask you how far it is from your house to the grocery store, you might measure it to be 10 miles, but maybe it was really 9.7 and you just said 10, or maybe it was 10.2 and you said 10. So there's a little bit of rounding that went into your answer on that as well. Okay, so let's go back to age with that in mind. Okay, and let's say that I ask a student how old they are, and they tell me 17. Okay, now, does that mean that that person is exactly 17, or could they be a little bit less, or could they be a little bit more? All right, so we know that, like, for example, if a person was born on January 1st, and they turned 17 on January 1st, by now they're 17 in a few days or a few months, depending on what the date is today. Okay, but they're not 17 exactly. Okay, we can be 17 and a half, we can be 17 and 8 months, we might even be 16 and 11 months, and we might get rounded up to 17. We're almost 17, but there's definitely that rounding that goes on for age. And because of that, I'm going to put age down here on the continuous, okay? Because an age of 17 could actually be any two values between, or it could take on any value between two set values. Okay, and again, usually you don't need to use that. Usually you can say, am I counting or am I measuring, and decide based on that. If you get confused, think about whether that value is a fixed number or whether it's a value that can become any number between two specific values. All right, so as we finish this up, let's do a real quick example, and let's note discrete or continuous. Again, my recommendation would be that you pause the video here and work the problems and then come back and check. All right, so number of street corner mailboxes. That should be discrete. I can count the number of mailboxes. Relative humidity levels. I'm going to have some instrument to measure humidity. All right, so humidity would be continuous. Number of bananas in a bunch. That would be something that I would count. I can count the number of bananas, so discrete. Ages of women when they were first married. We've already said that age is continuous. We talked about that just a minute ago. Weights of backpacks. We also said that was continuous. We just talked about weight being measured with the scale. Number of students each day who make appointments with the math tutor. I could count the number of students. Duration of marriages in America. Okay, that's time. That's like somebody's age. You might say you were married 10 years, but maybe it's a little bit less, maybe it's a little bit more. You would still say 10. So I would say continuous on that. And we have another age one for the last one, which would also be continuous. All right, so again, what you need to focus on here is you need to be able to, if you are given an example, you need to be able to determine qualitative or quantitative. And then if it's quantitative, you need to be able to determine discrete or continuous.